Hi everyone, let's solve the last question from the weekly contest 333, that is find the string with LCP. So in this question we define the LCP matrix of zero index string word of n lowercase English letter as an n cross n grid such that LCP of ij is equal to the length of the longest common prefix between the substrings word of I n minus 1 and word of j n minus 1. So let's see what that line means. So let's say we were given a string as A, B, C, and D, right? This was a string that was given to us, and we have a matrix LCP. So let's say we have LCP 2, 3. So 2 represents that you take from the second index to the last of the string, that is BCD you take, and 3 represents that from the third index you start and you take this. So these are two substrings of this particular string. So the longest common prefix, right? In this case, we don't have any prefix which is common, so it is 0, right? But I hope you get the idea that we take these two strings this way, right? We cut the string from the second index and we cut the string from the third index. So we get two different substrings. And this LCP of 2 comma 3 just represents the longest common prefix that we can get. Let's say if we talked about LCP of 1, LCP of 0 comma 1, right? In that case, what string we would have got? We would have got A, B, C, D from 0 to n minus 1, and from 1 to n minus 1, that is A, B, C, D. So if you see that this A, right, this is the common prefix that we have in both the strings, right? So the length is 1, right? So LCP of 0 comma 1 is 1. So that is what this line means. Now let's move forward. Okay, now let's see. So now we are given this matrix and we have to return the alphabetically smallest string word that corresponds to this LCP, right? If there is no such a string, we have to return an empty string, right? So let's see. For this first test case, let's try to derive it, right? So we are given this matrix, right? Let's draw it. It is 4, 0, 2, 0. Okay, wait, let me draw a little lower. Okay, so we have 4, 0, 2, 0, and we have 0, 3, 0, 1, and 2, 0, 2, 0, and 0, 1, 0, 1. Right, now what we have to do is we are given this matrix, right? Let's also write its index. 0, 1, 2, 3, 0, 1, 2, and 3. We are given this LCP matrix, right? And what we have to do is we have to form a lexicographically smaller string, right? So let's see how we'll be forming this. So first thing is the string is lexicographically smaller if its initial elements are lesser, right? So let's say we have A, B, and C, that and we have A, C, and A. We are given these two strings and we have to find the lexicographically smaller ones. So as we see, these two characters are similar, right? So we first find a differing character, which is B and C, right? So whichever has less value, that appears first in the dictionary. So it is lexicographically smaller. So as here we will be starting from an empty string, right? So first we'll be doing what? We will be filling the string with A's, right? Now let's see. So first one thing is clear that this is n cross n grid, right? 4 cross 4 grid. So our string length will be 4. So there will be 4 characters. Now this position simply represents the whole string, right? From 0 to 0. So we don't have to see this. Now we will come here, right? We are saying that whatever the string is, right? So when we consider this particular string, right? So we have 0 and we have 1. So we will be having this case, right? So we are saying that the second character is not similar. That means we can fill this first character as A, right? And because second character is not similar, because it is a 0 here. So what we will do? We will fill this with a different character, but that character should be less, right? So we will fill B here, right? And after that we come here and we see, okay, wait, and after that we will come here at this particular index and we will see, okay, so this is from the second and to this. So we are just considering these two indexes, right? We are saying that these two are similar, that these two are exactly same, right? So first we will fill this particular value, we have filled with A, right? But then we come to this particular index, we can see that this is 0, right? This is 0, that means the last character is not same. So what we will do, we will fill this with B, so we will be getting AB. So right, so that is the answer to this test case, and this is the lexicographically smallest string that we can obtain in this case of LCP, right? Then there is another case, that when it is not possible to form any string, right, we have to just return an empty string in those cases. So now I hope the question is clear to you. Now let's see how we'll be solving it. So first let's see the cases where we cannot form any string out of this LCP matrix that will be given to us, right? So the first case is when LCP of 0, 0, it should always be equal to the length of the string, right? That is n. So like for this example also you can see it is 4, right? So for any case, if this is not equal to n, right, then we cannot form an LCP, then we cannot form any string. Why? Because if we have A, B, C, D, right, and we are considering from 0 to n minus 1, and here also we are considering from 0 to n minus 1. So it is the same string, that is the whole string that we are considering. So if we are considering the whole string and if it is not equal to n, then in that case we cannot form any string, right? So this is the first case in which our LCP, in which our string will not be formed. Let's see the second case. Let's say if I consider LCP of I and J, and then I also consider LCP of J and I, right? So this is the string. This will represent two strings, that is one string from I to n minus 1 and one from J to n minus 1, and this will also represent from J to n minus 1 and from I to n minus 1. So these should be same, right? The values of these two indexes of the LCP matrix, they should be same. But if there is any case for which these will not be same, right, then also we will not be getting any answer, right? So this is the second case, right? So let's see the third case in which we will not be getting a string. Let's say if our LCP of, here if we consider, if our LCP of I comma J, right, is greater than 0, right, then if we consider LCP of I plus 1 and J plus 1, then it should be, this is representing that ith and jth character in this particular string are same. For example, if you see for 0th and 0th position, this is same. If you consider for this is the same string, right? Let's say we had an string A, B, C, D, and now we are considering 0, 1, right? A, B, C, D we will get, right? So if you see this and this, that is 0, 1 of this particular LCP. If it is 1, right, it is greater than 0, then if you see the next character will be less than minus 1, because these two characters were same. Then if you are cutting it, like cutting one more character, that is this ith and jth character you have cut from the string, you move forward one place, right? That is, you come to this particular index, you check for these two characters, right? Then this character is deleted. That means LCP of I plus 1 and J plus 1 will be LCP of ij minus 1, right? So if if we don't have this condition to be satisfied, right? If this condition does not satisfy, then in that case also we can say that we cannot form any string, because this should be true. Why? Because we simply saw I and j will be equal, right? When it is greater than 0, LCP of ij. So we are just removing I and j only, right? We are moving to the next character for both the substrings. So that means it should be, we will also delete this character from this answer, right? So we will do -1 from this particular LCP ij. So we will be getting LCP of I plus 1 and j plus 1, right? So this is the third condition in which our string will not be formed, right? Now, so these three are the conditions in which our string will not be forming, right? First, that that the 0 comma 0, LCP of 0 comma 0 should be n, right? And LCP of I comma j should be equal to LCP of j comma I, right? And also LCP of I comma j minus 1 should be equal to LCP of I plus 1, I plus 1 and j plus 1, right? So these three conditions are done. Now let's check for what other condition we will not be able to form the string, right? So if we consider two strings, right? Let's take this case only. Let's say we have a b b c d, right? Now we are considering LCP of 2 comma 3, right? So we will be cutting it from here and from here. Okay, let's consider it 1 comma 2. Okay, let's say we have 1 comma 2. If we have 1 comma 2, right? So we will be cutting from here to here, right? So let's write them down here. Right, let's write them down here. That is a b b c d, and we will be getting a b b c d, right? Now one thing will be there, that which one is the smaller string, right? Whichever is the smaller string, you can get only those much characters to be common, right? At max you can only get those many characters common. So for any case in which this value becomes greater, right? If this value becomes greater, let's say we consider cd here and bcd, right? Then two characters can be common, like at max two characters will be common in both of the string, right? So how can we calculate that? We will say n minus maximum of I comma j, right? So if you see I is 1 and 2, j is 2, right? So n minus 2, right? Which is n here is 3 plus 4, 7. That is 5. At max, these 5 characters can be similar. So for any case where LCP in the matrix is greater than 5, right? For 1 comma 2, then we can easily say that this case is also not possible, right? So this is the fourth case when we cannot form any string, right? So these are the 4 cases in which you will not be forming any string, right? So now let's see, if all of these cases are true, then how will we create an string, right? So as we saw in the first test case, what we were doing was, let's again write this matrix, right? So this is the matrix given to us. What we were doing, first we will consider an empty string, right? Then we will check all the values, right? We will traverse in this row wise, right? For each and every row we will check what values are greater than 1, right? Because when the value is greater than 1, then we can say that one character is at least common, right? So we will fill all those positions with a, right? So for the first row it will be a, so we will try to fill as much a as we can in the first iteration. So what is the condition? We will check whether this particular number is greater than 1 or not, right? If it is greater than 0, then we will be filling this. So 4 is greater than 0, that means first character is common, so we'll fill it with A. Then we will come here, we are seeing that this is 0, that is the second character is differing, we cannot fill any A here. Then we will come here in the second index. Then for this particular part, we can see that this is greater than 0, so we will fill it with A, right? And then we are again seeing that this fourth character, right, when we are cutting the string from here and we are considering the whole string, right, so this character is not similar, that means there is a different character we have to fill here, right? Then we will move to the next iteration, that is in this part. So now we will also increment this character. Now we will take B, right? Now we will take B. Then we will check again for this particular index, it is like greater than 0, so we will fill this, we will fill B here. Then again, if we come to this particular index, right, it is also greater than 0, so we will fill B here as well. Now we don't need to go here, our string has been completed. And if we go here, we can easily check, right? Here and here again it is greater than 1, right? And here it is again greater than 1. So this simply represents that second character is not same and here the first characters are not same, right? So that is how we have to do this. Now let's see the code. So here, so first what we will do, we will check the conditions if we cannot make any string, right? So these are the 4 conditions that we discussed. This is the first condition, right? That 0 0, it should be n, right? If it is not, return this. Then we will be traversing in this matrix, and then we will be checking I comma j should also be equal to j comma I. If it is not, we will return this. Then we will also check I comma j. So whichever string has a smaller length, we can have at max only those characters common. So if for any case that becomes greater than the maximum characters that we can get common, then that case is also not possible. So we will return an empty string. Then for the fourth case, what did we check? If LCP of ij, if it is greater than 0, then LCP of I plus 1 and j plus 1, it should be 1 less than LCP of ij, because we will be removing ith and jth character from the substring, right? In that case also, like if it is not true, then we have to return this particular string, right? Now what we will do, we will create our string res, right? Here what we will do, first we have given the blank characters, we have just initialized to the string to blank characters. Then we are traversing in each and every row, and we are starting with the character A, and we are finding all the places where we can fill this character. So here we are filling this character, right? So we will fill all these characters with A, right? Then what we will do, here what we did, for the first row after we traversed, then we chose B, right? Then we chose B, and then we are filling B. Now there is this condition also, right? So I hope this is clear to you that we are traversing in each and every row, and for each and every row we are filling this character A, and then for the next iteration we will just increment the character up to Z. Now for any case, like as you can see, the string length is less than equal to 1000. Now let's say for any case, let's say the n is given 30 to us, right? If n is 30, and let's say we have used all the 26 characters, right? If we have used all the 26 characters and and n is 30, right? So there is a need to use 27th character. So can we use 27th character? No, because we need to get a string which contains letters from A to Z. That means we can only take 26 distinct characters and fill the string. We cannot go beyond that. So we are just checking for any case. If our character becomes greater than Z, then also we have to return an empty string, because that case will also be not possible. So I hope you have understood the problem. So that is how you have to solve it.